All right, so today, I'm thinking I'm going to switch things around. So I'd asked you to think about whether you wanted to go through the NiLearn machine learning thing. So you still get a little bit of time to think about that. In the meantime, we'll start with the reproducible research section of things. So before I get started with some of these things, let me get a sense of how many people here use versioning for code. How many people have heard of Git? Okay, I've got 6 hands, 7, 8, 9, a few more. Great. How many people have heard of GitHub? Okay, there are more people that have heard of GitHub than Git. That's interesting. Okay. How many people use GitHub on a regular basis? So that's a much smaller number. Right? And so, why do you think we should use Git and GitHub when we do research? So,
yeah, it's a good repository. You can get many developers provide their codes and some of the GUI applications also. So most of the time you'll see versions of even some of the versions which are more advanced. Even day by day they advances. So
okay, so I'll summarize that. So, can you guys hear me?
Yes.
Yeah. Pretty good? Okay. In that case, I won't use that microphone. So, the thing here was that you get access to the latest version of some of the software. One reason to use GitHub. But perhaps let me flip that question around. At a personal level, why would you use GitHub for your own code and projects?
I do bad things with my code on a daily basis, and when I do good things, it allows me to sort of make those add up.
So things from what you were saying, we change code all the time. And we get different results, same results, similar results, and an entire spectrum of things, broken results from code that we write. So how would you get back to a state where you saw something? And that's the essence of version controlling. So if you people would probably have, I'll come to that. So when we do research, a lot of research is done either through graphical things, not that. Just as we saw DSI Studio, it's a graphical interface. How would you repeat something that you've done in DSI Studio? You guys have all been using it, right? So how would you repeat it? How? Huh?
You could write down the numbers.
You could write down the numbers.
Log.
Okay. Is there a log that's built? I haven't used DSI Studio a whole lot. I like, as you might have guessed, to write code for most things that I do. And there's a reason for it. And partly I'm trying to get at this notion of, so some of you have done analysis with DSI Studio over here. The question is, how do you tell your collaborator, your partner in the project, how to rerun that same analysis? How? Can you? Sorry. Verbally. Okay. So walk me through a verbal instruction. Walk me through a verbal instruction. Okay. Load the file. Then.
You have to get the source file. Sorry.
All right. So some basic steps I think would be straightforward to convey. Loading files, but you do a lot of interactions by pointing and clicking on things. Are those recorded somewhere? No. So how do you get from the process to the final output that you got? So in that last presentation, there was data that was output from DSI Studio that was imported into MATLAB. If I wanted to repeat that process of getting that data, would I always be getting the right set, the same set of data? How do I verify that?
you have to load the configuration files, the number of tracks, the reconstruction algorithm.
All right.
Yeah, they haven't even started scratching the surface. Yeah.
So there's a lot of things, but so these graphical tools are appealing from the standpoint that they're point and click. It's like a point and shoot camera as opposed to your manual film camera or your DSLR, right? So when you're dealing with these graphical tools, they make life easy from a certain perspective, but really make life really hard from a long-term perspective of research. Because the interest in research is that you're getting a result, you should be able to convey it to somebody, and that person should either be able to replicate it, repeat it, or be able to use the methods in the same way on their data. And a lot of research that's done through these graphical tools doesn't necessarily give you control over conveying that information. Very often, certain parameter choices are hidden, and you're reliant on default configurations. So, even if you were to use DSI Studio, what's one of the first things you may want to note about it in a paper? I use DSI Studio, or would I say something more than that? Version of DSI Studio. At least that's a good first step, because hopefully, and this is not true across software versions, especially in neuroscience, people update things without changing the version of the software. But these are all important because they affect what you're doing with the tool. And so versioning is important at every level of the research process. And what we're going to talk about today, so I was assuming that I would get to hear a lot more people using version control of code. So we were going to start with version data. So something that even people who do version control of code don't think about is versioning data. But your data changes, right? So let's even think about not data that you may download, but that's also possible. So everybody here has heard of the Human Connectome project? Okay. Does anybody know if the original download set of the first 100 subjects of the Human Connectome project are same or different from the current release of those same 100 subjects in the Human Connectome project? No. But there are lots of papers out there which were written when that first release was created. So it turns out they're quite different. The entire reconstruction algorithm, the piece of code that takes the K-space images, so in an MR scanner, you get images in complex space, and that gets converted through some math to what you see as a visual image that you load up in FSL View, DSI Studio, etc. That very process involves a step called reconstruction, which combines this K-space data into images. That algorithm was changed significantly between the original release and the final release.
Recently, the 70 pre-processing data was thrown out.
Yes. So the 7 Tesla data from the Human Connectome project was recently yanked from its online presence because there were some problems with pre-processing. And they're going to release it, but now the expected timeline, I think, is October or something before it comes back. So data change even if when you don't think it does. And especially when you have your own data, you might run conversions on it. So converting from DICOM to NIFTY, for example, for a variety of things that you do. And that converter may change how the data is output. So just like many things, you want to be able to know that what your input was to a process that you showed results for is still the same. And that's where versioning comes in. We're going to talk about Datalad, and I'm going to, this notebook again was designed to run through the Jupyter setup. I'm now contemplating whether we go through that exercise of setting things up again, or we can simply use the shell. So I heard yesterday that many people aren't very comfortable with the shell, but this might be an exercise to get you a bit more comfortable with the shell. So what we're going to do is we're not going to do port tunneling. We're just going to log into the machine. So SSH into the 254 machine. And we are going to launch a Docker image in there. So if you're running Docker yourself, you could do this separately on your machine, but if you are not running Docker on your own machines, we'll log in and we'll still use the Docker image, because that has all the code we need if we're going to play with here. Okay, so I'll let you guys log in while I still talk about what you're going to do in terms of reproducible research. So versioning is one aspect. You've got data. What do you do with data when you're doing research? I heard a bunch of presentations this morning. They did things with data.
Manipulate it.
Huh?
You manipulate it.
You manipulate it.
And more data.
Right. You manipulate data to get more data. You manipulate it in different ways. So the second piece of this is, under what circumstance do you manipulate the data? I see a lot of laptops over here. And I can probably guarantee that not a single one has the same exact environment. Right? So and many of these laptops use DSI Studio. What are the guarantees that DSI Studio works the same way across all those environments?
Should be pretty good.
Maybe, maybe not.
Okay.
Don't know the answer. Possibly, with something like DSI Studio, everything is encoded in the binary of DSI Studio. So as long as you're running the same version and release, you're likely doing the same things. But that's not true of a lot of software you use when you're doing neuroscience research. A lot of those software rely on operating system level libraries, things that can actually have quite a bit of an impact. So we did a study not too long back where we looked at a very simple workflow. All it did was use FSL, which is a tool you guys have now heard about, to take a structural brain image, and it would extract the volume of the subparticle structures from that structural brain image. So it's a workflow we call the simple workflow because it's really simple. It's a few steps. And we then ran this across different environments and asked the question, how stable are the results? And what it turns out, so no change in the actual version of FSL was done, but you got up to 7 to 10% on average differences between the volumes of some of these cortical structures. So when you read a paper that reports differences on the order of 2% or so, it should immediately raise a flag. Is that within the variance of what the software has, or is it a real variance we are capturing? So how do you get around this? So one way to get around this is to make sure that your environment that you use is consistent. Number two is to make multiple environments that run the same kind of things. So most software that are produced out there don't test variability across environments. And we'll talk a little about this tool called NeuroDocker, which we'll be building, which allows you to build Docker images for different environments and operating systems. Now, that's not going to be able to do the OS X versus non-OS X test because Docker runs Linux kernels only. But it at least gives you an idea of how stable an algorithm is that you're using in one environment versus another. So you want to understand the variability of your environment. And then the third piece is data flows. And by data flows, it's closer to the manipulation thing that he was talking about. The various algorithms that you're using, whether it's DSI Studio, whether it's NBS, how can you capture what was done there so that you can repeat things? The goal should be that you should be able to, without much verbal instruction, convey to a person sitting next to you, this is how you repeat my analysis. That really should be the target of any researcher. Unfortunately, it's not quite the target of most researchers today, but that really should be, because once you have that, you can swap out things. So you can swap out the data with your data and still run through the same workflow. When you read a paper, how many times do you say, oh, I wish I could run that workflow? And how many times do you say, I can't, it's too complex? A lot of the times, right? And that's because most of the time those workflows that are in publications aren't encoded in a way that make it easy for you to rerun things. The set of tools that allow you to do this are available. And if you can start adopting these tools in your own work, then it becomes easier for you as well as the next set of people who are going to look at your data, look at your tools, to be able to reuse these. So we're not going to touch any of these things, but a key element of all of this is this idea of provenance. So for those of you who've heard of art sales in art shows and auctions, provenance is very important for every piece in an auction. Provenance means, where did this thing come from? What's the history of these things? So when you look at a result in a publication, that should be the first question. How did this result get generated? More than what the result is. I mean, what the result is your knowledge nugget that you take along with you. But you want to trust that knowledge nugget. And the only way you can imbue trust in it is to say, how did they go about getting this result? So most of the time when I read a paper, if I don't get past the method section, because I get stuck most of the time saying, I have no idea what they did, so I can't trust any of the results. And that needs to change in the culture of science. We need to be able to know how somebody has operated on data. And that's what we're going to go through today. So you've already been introduced to NiPipe a little bit, but you use NiPipe not to create workflows, but just to run pre-existing workflows. So we'll do a quick introduction later on in kind of creating your own workflow. It won't even involve any imaging. It's a simple workflow generator, and I think I heard Pierre showed you how to use a graphical interface to construct NiPipe workflows. So that project seems to be coming along really, really well. So this may obviate the need for coding, but if you can code, I like my fingers. It's closer to playing a piano than moving a mouse. I don't know what that's closer to. That's like conducting, perhaps. But we'll start with versioning data. And along the way, I will talk about Git a little bit. It would be useful to understand Git fundamentals a little more, to understand what Datalad and Git Annex are doing. The tool we will be using is called Datalad, and it's available in that Docker container that you have. So since we are going to be pulling data from the internet, one of the things we're going to do is to try and mount different data locations into the container. So I'm going to pull up my terminal, and in your shell, whether PuTTY or SSH or etc. So I'm in VM01. One thing we could do is kill every single Docker instance that's running. Can I do that? Okay.
Anyone running any background Docker jobs? No?
Just kill.
Best time to learn what's in Docker, right? You just go on the next time that you open it up.
Okay, we'll see. It's going through and stopping every single one that's running. Now it's good. All right, so there are no more Docker containers running. And so what I would like you to do right now is make a directory for yourself. And since we're still looking at unique things, I would just say make a directory with these 5-digit numbers that you have, because that's already unique across everyone. Okay, so I'm going to create a directory called 6223. So make dir is the Unix command for creating a directory. after you've made your directory, I want you to run this command. For various reasons related to the setup over here, Docker won't be able to write out things into that directory. So what this will do is give permissions to Docker. So chmod a plus w, and then your 5-digit number. So don't run the Docker command just right this minute. I want to explain what we're doing again with Docker. It's good to repeat it a couple of times while you play around with Docker, because this is going to be the exact same thing that you do on your personal machines when you download Docker. It doesn't matter that this is running on a VM over here. So everybody has created the directory and changed permissions? Okay, anybody still not there? Okay.
So you're connecting the localhost as well? To the phone?
You can, it doesn't matter too much, at least for this present moment. But if we do this 5 times today, you'll just get better at Docker. So that's my goal. That we run this 5 times in different variations, and that way you get to see when you tunnel, when you don't, when you can operate on the shell. Okay. So at this point, I'm going to explain this command line here. So you've seen variants of this: Docker space run space -it, which means interactive, --rm, which means after I'm done with this container, kill this container. So when you exit from the container, it doesn't have a Docker process that's running, or a stock container, which takes up memory and other things on this space. The -v option is going to now take, so $pwd, present working directory, tells you that I'm going to mount this directory that you just created, so in this case it's my directory, into the container at /data. And then the last bit of this is the Docker image that we have been using. So this will get us into the container.
We need to make the use of npda command and make the directory, and after that we will directly run this.
No, so after you make the directory, you want it to run this command. And what this command is doing is giving everybody permission to write into this directory. If you're on OS X or on Windows, Docker normally handles this for you, but in the case of Linux, you have to do some fancy things to make it work, and this Docker environment isn't quite set up to do that. So ideally, every one of you would have a single user account as opposed to using a common account, and then that account would have permissions between the container and the outside world that would allow mapping. So if you do this, we are just kind of saying, let the container write to things outside. And I'm going to show you that at least my directory right now, empty out what I have. You don't have to execute this. There's nothing inside that directory, which should be the case for all of you. There's nothing inside it. So now we can run this command with your 5-digit thing over here. And that should Now you can hit enter, that should get you into the container. And what I want you to do is do something very simple, which is, there's a Unix command called echo. And if I say echo me, myself, and I, all it does is it writes it out into the file.
Hello world.
We've got too much hello world today, so
This is called brain.
yeah. And then you're going to write this out into a file. So remember, we mounted that outside directory into /data. We're going to write it into a file there called foo. Foo is computer jargon for temp. Everything is called foo in computer world. Okay, now we exit the container. So you can either type exit or hit Control D. And then you're going to check if you have this file in the directory that you created. So all this is doing is just a brief intro to say, I have mounted something from outside on the system into Docker. We wrote something into the file with this command. And at this point, I would really like you to just type, because that muscle memory is going to be useful instead of copying and pasting. And then we exited the container. So now we're outside the container, back on the home system. And if you do this, replacing this number with your number, you should be able to see me, myself, and I written on the screen. So, went into the container, wrote this string into a file, exited the container, and outside the container we see that that string was written to the file and that file was created. And this pattern, just a simple thing of mounting data from outside the container into the container, doing something, getting out of the container, is what's going to be useful to you in trying to make sure that your environment is consistent as you do your research. ESX2B is not going to work, but there are other things that you can use instead to compute the same GQI values from inside the container. Yes?
Just going over the Docker line again.
This Docker line?
Yeah.
Okay.
So pwd present work directory, and then you
Slash.
going into the directory that you created.
Yeah, so this is just naming it. It's just a full path to the directory.
And then so the /data, is that assigning a path? That's
It's
not a path.
assigning a path inside the container to that same point
All right. So the data would be equivalent
of that
slash.
outside directory.
Okay. Yeah.
So, and this is true of Docker, and I'm not going to go into Singularity right this minute, is that this path /data doesn't exist inside the container. So if I don't do this, so I'm removing the path, I'm not mounting anything, I go inside and I use ls/data. So ls is the Unix command for listing thing. It says there is no file or directory. So in that machine, there is no /data thing. That was something that Docker automatically creates because of the instruction we gave it. Okay. And that's what's going to be useful, because you don't want to store your data inside the container. You want your data to be in a separate location, because that's what you want to keep reusing with different things. And okay, so at this point, what I'm going to do is I'm going to try and make this even more legible by making it half the screen. I'm going to try and hold this. We'll see how well it fits. So we can now go back into, so everybody had whatever string they had put in outside the container. Were they able to get to that bit? Yes? No? Almost?
Yeah, we have the stickies.
The stickies, yeah. Maybe I just ask you, if you're stuck, just raise your hand today. Yes. Okay, so tell me about it, because I think it's good to just discuss it, what you're...
I have given the directory name and then CH more A plus, that being 18911,
Yeah.
and the Docker run it. Then I got a command that I'm able to find the image, Satra/IBRO.
Dash
Not here, I think
2017?
before this itself, I'm not going in here. Initially itself, I'm just
So, did you...
before this, initially, after me, the directory itself is not able to, something I don't understand.
So the error that you mentioned, which says image not found, has to do with that this name wasn't typed properly. Dash 2017.
Yes, yes, yes.
So if you run the Docker command in the directory that you have created, so the 1111, and then if you echo something to within the container, and then you try to save it,
It says error.
so you will say error if you don't explicitly define the DWD.
Correct.
Okay.
Yeah. So this is true of the Unix Docker, which is it won't have permission to write to that location, whereas it was a non-mounted location,
Okay.
and
Unless
it
you specify. Okay.
and it will create an error. So this command is exactly the same command I had used earlier to get in. It's not different. Yes. Did you do the CH mod step? Because you run the command from inside the directory. That command is outside the directory. So you can't find that location. Yes, so that location is now inside there. So it's 56312, and it's trying to find another folder from 56312 inside. So you need to come out to one level and then run the so maybe I can explain. So I think this is the same question that was being asked. So what some people did after creating the directory was go into the directory. Okay. And here, this command doesn't quite work, because this command is now saying mount my current location, which is inside the directory, and then mount this 6223, whatever it is, into /data. And this doesn't exist, right? Because if in this location where I am, I do ls$pwd/6223, it says, I don't know what it is, it's not there. And the reason is because I'm in the directory, right? So the Docker command I ran should be one level up for this to work. So I'm in the root directory of my account. Here, that $pwd/6223 is accessible, and you can go in. So these are all things with Unix shell that once you get familiar with using this, it'll become second nature. If you haven't used these things before, it's completely understandable that people are tripping up over this. So please make sure that you mention whatever you're running into, because other people are likely to be running into similar issues. Okay, so at this point, we go in there. We do ls/data. And we should have that same file over there that we had created. And if we cat this file, we see that same string. So the same file is accessible inside and outside the computer. Okay. So this brings us to versioning data. We're going to use a tool called Datalad to version data. But before we use Datalad, one of the things I'd like to ask you is, how much brain imaging data do you think you have access to publicly? Two gigabytes, 1 terabyte, 5 terabytes, 100 terabytes. At this point in time, there's probably about 15 terabytes of directly accessible brain imaging data. Things that you don't need to sign up for and get access to. You can just point to a place and download things. That's a lot of data. Now, then there's data, so I heard about the MGH data set. That requires a sign-up process to get access to. That's not directly available. The Human Connectome project data, that also requires a sign-up process to get access to. But I'll still put those in the realm of open access data, because those sign-up processes are not too cumbersome. They're meant to primarily protect the data as opposed to restricting individuals or assigning various kinds of clauses as to what you need to do when you write a paper with that data. So as an alternate example is the ADNI data, which is an Alzheimer's disease neuroimaging initiative data, where if you do anything with it, you add the ADNI consortium as the last author of your paper. So there are different levels of access to data, and they have to approve every project that you apply for. Now, one of the data sets that's coming online is the UK Biobank data. That does require approval to get to, but they're making it worldwide available, and that's an incredible data source, because they're basically taking 3 scanners situated around the United Kingdom and scanning 100,000 people on it. And all of that data is going to be made available. They already have about 12,000 of those samples available. So as a single uniform collection, that's already the largest collection of imaging data that's available from a single point. Together with that, they have genetic data. So they've already released 500,000 samples of genetic data. But those data sets, A, require them to approve your project, and B, requires payment. So it's not directly accessible data. For the amount of data that they provide, the payment required is fairly minimal. They have to maintain distribution and characteristics. So it's not so much that they're trying to make money off of the data. They have to maintain the infrastructure to disseminate and continuously curate the data.
How much are they charging?
It depends on your needs of data. So for someone like us who want the whole, pretty much everything, it's about 2,500 pounds. Now, 2,500, how many people here do brain imaging? Okay. Roughly speaking, do you know how much it costs to do a scan?
It's almost 5,000 Indian rupees approximate.
Okay, that's actually very cheap by international standards.
Yeah.
But even at that price, how many scans would you do for 2,500 pounds?
78, that's another.
Maybe 100 scans, roughly speaking, 200 scans.
Kind of, yeah.
So nowhere close to the 12,000 scans that are currently available and the 100,000 scans that will be available. Now, this doesn't mean people should stop collecting data. There may be specific questions that you need to answer, but you should sincerely look at your question and see if a publicly available data set answers that question. And don't collect data if you don't have to. Yes?
I was just going to say, like, this is all UK-centric data,
Yes.
but I guess all of the data that you would be getting otherwise is probably your locale-centric anyways.
Right. So there are a couple of reasons. So actually genetic studies is a good example of why you should get data from all over the world, because you want different heritability factors, different gene variants around the world. And that's true of imaging data as well. But the question you're asking is often not directly related to your locale. If that was a question, you'd be collaborating with somebody to collect data from 2 different locales. So often the cognitive science question that you're asking, you can at least do a preliminary attempt to answer that question using publicly available data before you start collecting your own data. And that might actually be a useful thing to do. And then the question is, at what scale do you need data? So these days, when people submit papers on autism, for example, and if it happens to use resting state scans, they're often told to repeat the analysis on a publicly available resting state data set. So that also gives you, so even if you're collecting your own data, it gives you a verifiability standpoint. Do I see the same results in a different data set? Okay. So Datalad, and we'll look at Datalad's online repository website for a second. Is a tool that's been developed, built on top of Git Annex, which itself builds on top of Git, to provide access to versioned data. And at this point in time, there's about 10.3 terabytes of data that's available through Datalad. So that number 10.3 is over here. This website, which is where Datalad repository information is housed, only puts out 151 gigabytes of that 10.3 terabytes. And the reason they can do that, and the reason why Datalad and Git Annex are a useful thing, is what it's saving is the metadata, where this data is available. It doesn't redistribute data that's available from a different location. So for public data, much of this data is actually coming from something like Amazon S3, where other people have made it available. What Datalad does is it says, we will give you a tool to search for data, we'll give you a tool to version data, we'll give you a tool to get data from different places. Now, it's built with a neuroscience or neuroimaging focus, but Git Annex, which is a software underneath Datalad, was built without a neuroscience or neuroimaging related focus. The intent behind Git Annex was, I have MP3 files in various places and hard disks. I can't store my collection of MP3 files on my computer. It's too large. So I'll only pull in the relevant pieces of MP3 files that I want to listen to at this point in time. More generally, Git Annex also does things with direct podcasts. So you can write scripts with Git Annex that pulls in podcasts that you want to listen to on a regular basis. Once you listen to it, it can remove those, and you have versioned information of those podcasts locally. So it's a very powerful tool for versioning data. If you were the kind of person who really wanted to see if particular websites were changing on a daily basis, you can use Git Annex to archive the website, and you can look at the deltas between those websites to see things. So it's a general purpose tool to have versions of digital documents. But these data files are really large. And the way Git normally works is that it stores these files locally. And so you get multiple copies of the files if you were to use straight up Git to store data. So if you use Git as a version control system and you add a data file to it, suddenly you have twice the space used because Git will make a copy of that data into its internal metadata store. What git annex does is it says, I'm not going to make a copy, I'm going to make a soft link to the data. So the only place where the data exists is in the internal Git repository. The outside place is simply a link to this file. So that way it keeps only one copy of the file, unless you start modifying the data. So if you modify the data, it will maintain multiple copies of files if you ask it to. And so your Git annex or your Datalad repo can grow. But before we get into that sort of thing, let's go through and look at some of the help. So I'm going to post this link. I'm not going to ask you to pull up. I'll put it in the Scratchpad, which is linked to the Google link above. And the only thing that I'll ask you to keep in mind as we go through and try to repeat these things is that within the context of the notebook, I escaped every command line interaction with this exclamation mark, which is how you would run things in the shell. When we try these over here, you have to ignore that exclamation. So if you're copying and pasting, you should copy past this exclamation point. And I will go through every single command briefly just to ensure that we're on the same page. So the first thing with many of these things is you can ask for help. So datalad -help NP. And it's really hard to read it when it's that small around those size. But it does provide help. So it tells you what commands are available. You can interact with things. And the nice thing about doing either programming scripts or shell scripts is that these commands are repeatable. You can ask other people to do these things. So I'm going to switch back and forth, unfortunately, but if you get there and copy it, you'll have access to the lines that we are looking at. Just for sake of visual clarity. So with Datalad help, you get access to a whole set of commands. We're not even going to touch 90% of these commands today. What you can do is, you can also ask for help on subcommands. So the second thing that we have over there is Datalad needs to install this metadata dictionary where you search for things. And we can ask for what that command looks like. And again, I'm not going to go into detail, I'm just saying that there's information available on these things that you can look up as you work with these tools. So what we will do now is ignore this %% bash thing on top of the Jupyter notebook and go down and do the commands that are listed there. So we're going to cd, which means change directory, into /data. I would highly recommend opening the page because I'm going to switch back and forth. So if you're trying to copy it from there, cd/data. So this is your data directory that you created. And then inside it, I'm going to run this magical command with 3 slashes.
Is that an alias for other things?
The 3 slashes, it's an alias for Datalad's root metadata store. So this will basically clone at this point all the top level datasets from Datalad. That's a lot of data none of it is sitting on this drive yet, but a lot of the metadata is. Okay. So I use the ls command to look at those data sets. You can also use the treat command, which simply goes treat. And since I'm going up to such a level, it escapes my screen. It gives a nice visual representation of your directory structure. That's what the tree command does. Okay, so we have some data, actually metadata. We don't really have data at this point in time. So what Datalad also allows you to do search on the metadata that it knows about. So what we're going to do is copy this command in cell 8. So when I say a number, you can look up on the left column of the HTML page that you've loaded, which number I'm referring to. So if I copy that command, again, without the exclamation point, and put it in here, I'm basically telling Datalad that I want to search this data repository location where we put this metadata store for the term Haxby. And what it's going to do, the Haxby here refers to Jim Haxby or James Haxby, who's done a bunch of things in cognitive neuroscience and other places. It's going to return any data sets that are associated with him that are in Datalad. And it tells me that there's 1, 2, 3, 4, 5, 6 different data sets which come from all kinds of different locations that are associated with Jim Haxby. You introduce them to BITS a little bit?
Yes.
Okay. So if you've heard of BITS, Chris Gorgolewski is the person who's been developing BITS and getting the community together around BITS. So we can ask for the data sets that are associated with Chris. And if you can't spell his name, it is on cell 9 of the HTML page. Yes?
I'm not able to reopen Jupyter. I'm not able to reopen Jupyter.
But the URL that you had is just an HTML page. It has nothing to do, it's remotely rendered. It's not your connection to Jupyter. It's not localhost.
Okay. It doesn't matter if I'm...
Yeah, as long as you're connected to the internet, you should be able to open that URL. So this is the URL in the Scratch, which is right below Jupyter Notebook Saturday. That's just served by an external server. So if you click on that URL, it should open in the browser. So here is cell 9 from that notebook. I'm not executing things in the notebook. I'm executing things in the shell. It's searching for Chris's data sets. And so one of the things you can see is that we've used this particular data set a couple of times, this DS000114. It's been used for this NIH workshop a couple of weeks back, and it was also used in the NIPAC workshop earlier in the year. Yes?
I'm getting an error, or maybe a couple of us have it, which is that no installed dataset found at data /datasets .datalad.org.
Are you missing a slash?
At the front, I have that, yeah.
So that top command isn't working?
So how do you even get to the slash data that directory?
This directory?
No, like at the front?
Oh, at the front, I had CD change directory into it. That shouldn't matter because we are producing an absolute path over here.
Oh. So just run Datalad.
So home directory, this is where we are. I can do Datalad over here. I don't need to go into Datalad, so I can, the search commands I had prior to this are that. But before I did the search commands, I had done this Datalad install.
Right.
And that I had done inside this directory. So, sorry, cd/data. So I'm right now in data, and I had run this command inside it.
Okay. So you have created a data directory.
No, the data directory should have come as a result of mounting. Remember when we ran Docker? So we are inside Docker,
Right.
and Docker would have created it.
Okay. Oh, okay.
Okay. You got it? Okay.
So I didn't get the full command, datalad search -d.
So this is in cell 8 of the notebook. I would highly encourage, go here and click on the link and open the notebook in a browser. So that in case you miss it here, you can actually copy it from there.
It doesn't seem to automatically create the
Slash data.
tree. Yeah. I've tried to CD to it and it doesn't.
So I need to see your Docker command.
Yeah.
Yeah, so that should create it.
So I'm still in the same type of system. So right, so even LS doesn't get out. Right, okay. Why is that though? I mean, why is it just
Yes, so we are mounting it not into a home directory inside the computer. You are in but we're mounting it slash data. So in the Linux world, this forward slash is the root location of the file system. So for those who are used to Windows, C:// or D:// is the root location of that particular drive. In the Linux world, slash is the root location. So when we mounted slash into slash data, we can see that data exists in this root location, but where we are, if we do cd inside our home directory, is slash home slash neuro. So that's the location we are operating in. The place where we are storing the data and doing all the operations on the data is slash data. And so when we ran the install command, we cd to slash data and then said datalad install slash slash slash. Yes.
I need to run with this faster or I need to write datalad search.
So this is the bit, so you should still go in order in the notebook. And so one of the first things in cell 3, so number 3, was doing this cd dash data and then datalad install slash slash slash.
Faster is the search, second is the install.
First is install, then search. If you search before install, it will install it in a different location. And since you want people to be at least on the same path, you want to ensure that it installs in the same. Okay, so were everybody able to do the install? Anybody not stuck at the install? Yes? Not yet? Okay. So you're on the VM? No, this is the command from yesterday. We're not using that command from yesterday. It's not there. So we didn't paste the command. I can paste it, but it's not the same command. So this is the command that we had for today. And I'll paste it into the scratch. And you should replace the 5-digit number with your own number. Oh, Hagsby is James Hagsby's name. He's a professor at Dartmouth College. So we are asking for all data sets that are associated in some way in data. Huh?
Is your keyword with slash?
Yes, it's a keyword. It's a search keyword.
It's a search keyword. Yeah. Yeah. No, that was earlier. Okay. So now you should
understand what is data.
Yeah.
Search. Now what is search for?
So to catch up, you should go here.
And it's a search that is just which version of the data answer has a common stuff. So often that means do not adopt the document is used for operating the document. Right? If you didn't know this, you have to download the data lab location where our data is stored. So that was the data, right? Install.
And then you should be able to run a search command. Yeah, which is the next cell, next active cell.
What's that? What data is that's a good search there. All, yes. So here we change different also links to the data. So all is done so far is to introduce you to the Datalad software that can link you to data sets in the world, and just show you how to install them by command and how to search. That's it. That's it.
Thank you.
Eric, I think you need to give both of those instructions to wider. You should just come up.
Oh, okay. So, dumbing down the language a little bit. Yeah, so just for people to kind of understand, what Dr. Satra is just trying to show you this morning is, A, there's a lot of open data sets out in the world. And he's trying to show you a tool that can tell you where these are and how do you access the versions of the data. That's Datalad. That's all you're doing, right? So this morning, all this, don't get too confused with Docker and stuff. So the key step is just trying to introduce a little piece of software called Datalad that helps you to identify what are the open source data available in the world, and that tool actually keeps track of the version numbers and the changes to those data sources. Okay, how do you access that data sources? Well, first you need to run Docker. There is a Docker machine that Dr. Satra has prepared. That is the Satra workshop thing. And you know you are in the Docker machine when you have this Neuro username, right? Otherwise it's IBRO KL, that's the server, right? And then the second is you need to install Datalad into this machine. You're just doing it by command line way. So what do you mean by install? You're just having a local list of references to where all the data is. And the third one, which is so the install one was the Datalad install //. And after you've installed it, this command says nothing else but how do you search from all these lists of links for one particular keyword. And here the keyword that Dr. Satra has chosen would be MPRAGE, which we covered in lecture 1, which is a type of anatomical imaging sequence. Or it could be someone's name, like Haxby, Richard Haxby, Jim Haxby is a professor's name, or Chris Kopolowski. Or it could be just something like DWI, right? So these are just your search terms. So he's just showing you how to search in using the Datalad system, but on a command line. So this morning, you do not need to run Jupyter Notebook on your machine because Dr. Satra has already Jupyter running on another server somewhere else, so you don't need to start it up. So the whole reason why we were starting it up yesterday was you wanted your own Docker machine under your own control with all your programs running. Okay? That's why you had to start Jupyter yesterday. But today, he's just giving you the link. The notebook is on another machine. Right? Is that okay? Is that clear? So the only thing you take home up to this point is, A, can you actually see this notebook? Right? Just copy the link on the Google page and can you see this notebook? Right? Okay. B, have you been able to log into the Docker machine? That means you see the Neuro username. C, once you've logged in, have you successfully installed Datalad? If not, just raise your hand or colored sticky and it will come around. Okay, great, Fidel. And D, if you've installed Datalad, do you understand how to search for a subset of those data links? and that is that Datalad search term. So if you don't, you can raise your hand and Dr. Satra will turn to you. I'll help with that.
Okay, thanks so much, Eric. So hopefully, most of you have gotten to this, at least being able to search for this. And we're going to try and download one of these data sets, the NIH 2017 data set. Okay, so that's going to be our next thing. And what we're going to do is, we're going to download the metadata for this data set. It's not going to actually download data, and that's the key difference I want you to retain. That there are multiple commands in Datalad which allow us to either download just the metadata, so it gives us the directory structure and other things, but doesn't actually get the imaging data. So the first step, we'll just do this, which is get the metadata. And the way we do that, again, if you're looking at the notebook, this is in cell 10. It's this command which says datalad install, and the path is the exact path for that search data set that we showed. So it's the same path we have over here.
So now it's looking at this location, looking for the list of.
And when we do this, Datalad goes and does its magic and gets hold of information that's in this data set.
Yes,
And it's going to try and work a bunch of things.
Yeah, one letter, sometimes small, big letter is enough to just skip. Okay.
And this data set is somewhat interesting, partly because it exemplifies a little bit of what Datalad can do. So this data set has two sub-data sets, which are not installed as part of this command. We'll look at the tree structure of this data set in a second. The main data, which is Chris's data, DS00114, comes from the Open Neuro, the Open fMRI release of that data, which is sitting on Amazon. So that bit comes from Amazon. Then, Chris has also processed this data with fMRI prep. And that doesn't sit anywhere. So he sent us a personal tarball of that processed data. We took that tarball and put it up on Dropbox. And what we can do with Datalad is, because it's pointers to things, we can point to Amazon for the main data. For fMRI prep output, we can point to Dropbox. And Datalad will fetch the main data from Amazon and the fMRI prep stuff from Dropbox. Okay. So it's very powerful in the way you can use it to point to different locations, how you version it, and all of this is versioned because it's in a Git repository. Okay, so in my case, if you were able to run that command, it should at the end say install OK:3. Did somebody not get this, or is it still downloading for some people? Still downloading. Okay, it takes a little bit of time. So this data set is a data set of 10 subjects doing 5 different functional tasks. It's a very straightforward, simple data set that we use for various tutorials. And then it also, because it has fMRI prep and FISR for output. Yesterday, when we were plotting some of the things or images, there's a version of this data set that's already sitting outside the container that you mounted, that we used yesterday when you were looking at the Jupyter notebooks. But today the plan is for us to get familiar with downloading data ourselves, because once you can download one data set, you can download other data sets. All right. So I'm going to move on to at least the next step, which is to try and show what's in this data set. So I'm going to use the tree command again. And the tree command is a Unix command. The -L or capital L3 basically tells tree, show me up to 3 levels, as opposed to many more levels. This data set actually has a lot of levels. And now I'm going to do one more thing just to page my screen. So I'm going to pipe this to less so that I can scroll down. Otherwise it would just come through and completely go through this thing. So we can see This has a file called changes, a JSON description. It has folders called derivatives. So this follows the bits format of the structure for data. And one of those folders is called fMRI prep, the other is called FreeSurfer. And then for every subject, it has the bits data set. This also happens to be a test-retest data set. So every subject had 2 sessions in which they did the same things. So even as a simple small data set, it's actually a nice data set to play with because you can test your tools or your software on multiple things. And this data set has an ANAT folder. So each subject for each session has an anatomical scan, a diffusion scan, and a functional scan. So for those of you who've been playing with DSI Studio, yes, this is not the quality of data that you get from the MGH Connectome project release. But it would be a nice thing to test how stable your network-based statistic metrics are between 2 sessions of data. It's the same person's data. So the other thing to note is I asked it to list up to 3 levels. So it listed 3 levels, 1, 2, 3, and didn't go further. But over here, it doesn't list anymore. So in the Datalad world, a sub-data set is not retrieved automatically when we give the install command. It just gets some of the metadata, and then we can do Datalad install further with that sub-data set. So we'll get to those steps. So these 2 folders actually contain a lot more data, but right now they are blank. They don't contain even the folder structure that we are seeing for other things. Couple of other things to note. So I mentioned that one of the features of Git Annex is that it doesn't make 2 copies of data. Right? So if you are storing large data and you're using version control, any kind of version control system would make multiple copies of the data because one, to keep it outside, one is an internal store. This thing that you see over here, dwi.bval with a pointer, is what in Unix is called a soft link. It points to a file inside the Git Annex store which actually will house the data. But this file doesn't exist right now because we haven't actually fetched this file. So soft links can exist on a Unix system without its target being present. So Datalad and Git Annex really take advantage of Unix features to make data easily accessible. So if we were to say, so all of you have done the Diffusion Studio, right, or over this workshop, so you know what a diffusion image is. So you know what a bval and a bvec file is, right? So if we are to take this bvec file, and cat it, cat being the same command we used earlier to see the contents of a text file, it will say no such file or directory. Because we haven't actually pulled the content of things, we've just pulled the structure of the data set. And this is quite powerful. I know it's a little alien to most people because you're used to clicking on something, downloading data, unzipping it, and everything is available. But what this really allows you to do is to get the pieces of your data that you're interested in. So as we are playing with 10 terabytes of available data, I don't have 10 terabytes of space on my laptop to deal with things. So, but I may be interested in only pulling the T1 images. That might be much less than 10 terabytes. That's very likely much less than 10 terabytes. And I can use something like Datalad to pull in only the pieces of interest that I'm interested in at a given point in time. With a growing scale of data, we are soon going to run out of space on your global laptops. Once you start doing anything at research scale, you'll need your cluster to pull these. But even there, let's consider the Human Connectome project data. Does anybody have an idea of the size of the data distribution of the Human Connectome project?
You know, there are other new technologies that actually store it, so that says
So they're still storing it on the same technologies. They were using a new technology to distribute it. But, okay, we talked about 10 terabytes of data publicly accessible, and since the Human Connected project required registration, I didn't consider it that direct open public pile. But it is an open access data set, and it houses 96 terabytes of data. Most of the time, when people download data, they don't need all of those 96 terabytes. They need a fraction of it. That's where things like Datalad can be very helpful, because we can create these sub-data sets for individuals in the Human Connectome project, and we can either download pre-processed data, we can either download just the T1 images, or the resting state, or the diffusion images, or the behavioral phenotypic information. We don't have to download all the data. 96 terabytes would take a long time to transfer. In fact, that's one of the reasons why they have this thing called a connectome in a box. They ship you drives. It's easier for them to ship drives. That's faster for you to take those and mount them in than to download 96 terabytes of data. So what we're doing over here is now we're going to say, how do we actually get hold of this data? So we looked at this. This is what we were doing. We said, show me the contents of the DWI file, and it said nothing. So now we'll use this command. It's a very simple command. Datalad get. So this place where we're saying cat, I'm going to type Datalad get. And at this point, a little magic happens. And now, I can look at the v-vals. So I didn't have v-vals, I got the file, I can look at v-vals. Yes?
So if we're attempting to have this side by side with the Git repo, I mean, it wouldn't make sense to have this inside of a Git repo, because any of the stuff that we get, Git experiences that exponential stuff whenever we change, right?
Not quite. So this itself is a Git repo. It's both a Git repo and a Git annex repo simultaneously.
Okay, so don't do Git init inside any of it.
Inside this repo, no.
Okay.
But we will create a data set a little later on ourselves. So how do you create your own Datalad data set? So when we go through that, that'll show you how to do that later. What I did instead is I used Emacs, which is an editor, to open a file. It didn't have this content in it. Now it's read-only because I've added it to Datalad. It won't let me modify it without unlocking it. But I pasted that piece of code into it and then ran it. So let's look at the history of what I did. So Datalad get in the data set, copy the data, looked at that data, then I used Emacs to create the file, then I executed that command on my data, I stored the output of that command into a file, I checked my Git status to tell me that all of this was untracked, so I added it using Datalad into the repo. That's about it. So those are all the steps. And that's is as simple as it can get with respect to tracking your analysis. So if you write code, and this is the part where using graphical tools makes it really hard. Because now you need, either the tool needs to have a good logger, which writes out what you have done with that tool, or you may have to screen record or screen capture, and then the only way you play it back is put the video on one side and try to replicate it on the other side. Whereas if you deal with scripts, if you deal with files and code, you literally can track every piece of the puzzle. Yes?
Once I've created the file,
Yeah.
how do I execute it?
So have you saved it? So the first thing you need to learn when you use Emacs or Bin, which are the two popular things, is how to quit those programs. So first you want to save the file, Control-X, Control-S, and then Control-X, Control-C. And now you can use the Python scripts command to execute.
I love that experience. People who try these things don't know how to quit.
I've run into too many instances. I remember when I first used them.
Yeah.
At that time, internet wasn't quite what it is today.
Yeah. But I mean, it sounds good when it's said that way.
Yeah. Yeah. Oh, we get addicted to these things all the time. So, because this is like dopamine coming. And once you get used to these things, they really, in the long run, save you a lot more time than if you say, this is too complicated, I don't want to do this. Yes, it's a good starting point because this is new, but trying to get used to this actually makes your long-term life much, much easier and simpler. And with various journals and other places who are going to ask for data and code, you have the complete history of things. So since Eric introduced you to BIDs, so there's a tool we've created called Hunicon, Heuristic DICOM Converter, which takes DICOM data and converts it to BIDs heuristical. So you have to give it information about your project and things. What Yarrick, who created Datalad, did was add Datalad support to that tool. So you go from DICOM, which is stored in a Datalad repo, so your DICOMs are stored, then the converted nifties are stored, and Datalad, as part of doing the storage, can say that the DICOMs are sensitive data that should not be distributed, and the nifties are less sensitive data that can be distributed. And then if you run operations on it, you can track the entire history from the origin of the data set down to the publication. So it's really a nice way to capture reproducible things for publications. And I don't think it's too far into the future that every journal reviewer and editor, or whether through mandatory practices of the journal, will ask for data and code that accompanies a paper. Socially it's still hard right now, but I don't think it's too far away where that social culture changes. Because all the technologies are becoming easier. So as more papers do actually do this as part of an unsolicited version, other journals are going to want to do this. And for, at least in the States, funding agencies want your data to be submitted. So again, data submissions become really easy when you track things with Datalad. Okay, did we do everything in that exercise? Let's take a look. Pretty much. So we had a pretty much script and output. So I can show you a little bit of what Git is capable of with this current state. So if I look at this, ls and tree, so I have all this data over here that I have added, the scripts that I've added. If I look at git log, it tells me I had done a fancy analysis and had done a fancier analysis, and I had this initial state called modified file. So I can actually git checkout this commit, this add modified file. It seems like prehistoric at this point in time. But now if I look at my tree, I only have that 1, 2, 3 object in there. Because that was my state at that point in time. Does this mean all of your other objects are gone? No, they're sitting hidden inside that Git repository. And if I git checkout master, which is Git's way of saying my current state, head, let's look at the tree again. I have all those things. So that's how easily I can switch between different states of my repository. So it's a really powerful combination of tools to be able to get from data to your output, to track these things and work with it. Yes?
Does Datalad support branching?
It's a Git repo, yes.
I didn't want to get into it here, but yes. So Git is a very powerful tool. Projects are getting more collaborative by nature. I'll be talking about NiPipe a little bit after lunch. So one of the things, we can take a look at the NiPipe repo. So we can see that NiPipe has had over 127 contributors to the code. If Git didn't exist, this would have been a major pain to manage. That's what Git allows us to do, is manage distributed code development and branching and logic around it. What GitHub does is adds a nice layer on top of it with the UI and other pieces to manage the social collaborative side of things. But the fundamentals really come from being able to use Git properly. And so there are many places to learn. One of the things we did create that I would recommend as a starting point. So we had an NiPipe workshop in Boston earlier this year, and a lot of the requirements are listed over here. So for example, knowing the Unix shell, doing version control, basic Python and scientific Python, and some neuroimaging basics. Each of these things are pointers to resources that you can learn things from. So Unix shell, it takes you to software carpentry, and it introduces the shell. It takes you through various basic components of things in the shell. Git version control also takes you to software carpentry and actually works you through Git. This is not Git Annex, this is not Datalad, the basics of Git, how you use Git for version control. Basic Python and scientific Python, this is a set of lectures where each section of it kind of goes through different scientific pieces. So I would highly recommend that if you're not familiar with these things, but these things appeal to you as a good set of tools, then go and learn the basics and work with them to understand how you can work with these tools. In addition, almost everything that we did in the workshop is available. So this is an older Datalad presentation using version control for code and data, but it again gets you through various concepts and components. And if you wanted to review how much you know about the world of data science, this is a set of review questions. And you can walk through them. And if you can answer things, great, you go on to the next step. If you can't answer things, there's a link inside each question that points you to a resource that you can use to study that bit. So are there questions about, and all of these links, you don't have to note them right this minute. I think we can send an email out later on or post it on the comments. Yeah, with all the links. In fact, everything I've shown so far is all available through pointers online. So you should be able to redo things at wherever you are. Okay, where did we reach? So are there questions about Datalad and Git Annex? Things that seemed confusing. Maybe it was confusing to other people. There's a lot of magic under the hood because we're making assumptions that somebody knows Git. And somebody that, even though we're just typing commands, implicit in our head are we know what's going on under the hood because we know Git. Whereas those same things are harder for people when they don't know what Git is doing underneath. What's the difference between a Git repo and a Git Annex repo? Things like that. Yes?
What does a Datalad merge look like?
So
Is it even possible?
let's find out. So I think create sibling is the closest form of that. So Git Annex has a merge. And so one of the things that once you get used to these things is that Datalad doesn't want to rewrite every command that Git Annex has. So Datalad is really providing slightly higher level commands on top of Git Annex. And so you will need to understand what Git Annex merge does, which is like Git merge. And unlike Git merge, you may have to give precedence to a particular branch for what supersedes. So it could be time-based precedence, or this branch has more precedence. Okay. Other questions? Yes.
Unrelated question. Data obtained from individuals who have, say, an intracranial mass and whole bleed, can that be used for any analysis? Because I assume the networks will be all disturbed.
So it really depends on the situation, I think. So we have various projects where we're dealing with lesions. And you have to approach the connectivity analysis in different ways, because many of the processing tools don't work on brains with lesions directly. So your typical processing tool might use standard free surfer parcellations or some other atlas that maps onto the brain. Now when you have a lesion or when you have a cancer or tumor, it distorts the brain. And so now you have to think about other ways in which you do these analysis. Now if you have a collection of these brains, most people, unlike reproducible research, I don't think there's a repeatable lesion across individuals. So you have to really think about what does group analysis mean in that context. And then your questions become important. What are you looking for? Is it exploration? Is it what parts of the brain remain the same? What parts of connectivity is partially distorted, changed as a result of the lesion? So if you have somebody with aphasia, left hemisphere stroke, depending on how far progress that is, some aspects of right hemisphere take over some of the functional connectivity aspects of things. So it really depends on the situations. With clinical cases, I think it almost becomes individual case studies type approaches. And I'm not sure connectivity analysis is at the level where we understand things at an individual basis. But you're going to run into issues with standard tools because most of them have been developed for control brains. And even when we think of mental health disorders, the brain structure doesn't change, unlike strokes and hemorrhages and tumors. But there are people working on those populations as well. It's just a much more difficult population because it's not that the tumor occurred in the same place for every single